And yeah, we have like 20 minutes before lunch. So I know it's been a long week and everyone's feeling a little like, okay, it's Friday, it's hungry, it's almost lunch. So I'm going to talk about something that might seem boring at first, which is tools and code. And if you're already getting sleepy, I'll try to keep it fun and exciting by showing you some interesting examples of how we put this toolkit to use. And hopefully keep you a little entertained along the way, as well as hopefully learning something. How many people were at the workshop we did in The Hague 2 years ago? Very many? I don't want to repeat a lot if everyone was there, but I see a lot of people weren't, so I'll probably cover some of that again. But I'll keep it brief for now, and then the afternoon we'll have plenty of time to go into a lot of the details, so I just will try to hit kind of the high points. And then if there's something interesting, we can follow up in the afternoon in our breakout sessions. But first, since the topic is web archiving and saving history and technology and personal records of our own existence in that universe, here's a picture of me when I was about 9 years old on a Commodore PET 20 computer. It was, I think, the first computer I ever used, and as you can see, I'm already programming. I think I was writing programming basic. But this really has nothing to do with everything else. I just thought it was fun to share with everyone. I have my own personal history out there of my use of computers and technology. So this, I'm going to use some slides from this presentation, which I gave last summer at Stanford. And I'll kind of, like I said, try to hit the highlights of the toolkit that we use at the archive. So everything that Chris was talking about, pretty much all of our analyses, everything we're doing to help improve our crawl cycles, all the analysis we do after the crawl is finished. Pretty much everything now is Hadoop, 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 Hadoop. We've been slurping more and more stuff into the Hadoop framework over time. And so yeah, so now almost everything is Hadoop based. In fact, pretty much all of our crawling now, the work files go right after crawler straight into our Hadoop cluster, and then all the interesting stuff happens there. We've kind of migrated away from, in the past, we might have had custom little scripts that would be running on individual crawlers, things like that. Now it's almost all in Hadoop. So I'll skip the introductory slides because I think you all know who the Internet Archive is. And I put this slide up there too early on, and it's kind of a lot of text to try to read on the screen, but the idea was just, what is web analytics? What does it mean, data mining? A lot of different definitions. Some are very subject specific. So, I like the top one, which is just measurement, collection, analysis, reporting of the stuff, and optimizing for web usage. So, it's really broad, and the idea is that this toolkit that we're trying to assemble can be used for a wide variety of different things. A lot of different interesting questions you could ask of it, and hopefully get the answer through this toolkit. It's also known now as big data. A lot of people are using that term, so you might hear people say, oh, big data this, big data that. It's kind of also web analytics. As you can see, I didn't use any blink tags. But to Jim's point, it's JavaScript. So anything that people said you can't do anymore in the web, like blink tags, you can do in JavaScript. So some of the challenges that we've talked about this week, and I won't go over them too much, but these are some very motivating challenges for this toolkit. One has to do with size. Like our web archives are like this giant ship, a container ship, just moving massive amounts of data, across the water from here to there. And when we're talking about analysis of web archives, at the Internet Archive, 0.0 is like 500 million, and we go up from there. So it's kind of like anything that someone says, yeah, I ran this script on my laptop and I'm like, well, that's interesting, but it doesn't really apply. So just to give you some numbers there, yeah, like our top level domain snapshots, typically in that range, if not bigger. Web wide is 100 terabytes or more. The full way back is, I think, that's actually probably quite out of date. It's probably closer to 5 petabytes now in terms of our entire web archive. The other issue, of course, which comes up a lot is, copyright. Problems, privacy, embargoed content. That has more to do with, well, what can you do with this information? It's like we've harvested it all, we have it, and you all have your versions of whatever you've harvested, but your ability to analyze it and share that analysis is limited. For the same reasons, oftentimes access is limited. You can't provide access because copyright, privacy, what have you. Well, then how can you share this data with other institutions? How can you share it with researchers? You know, maybe you have certain legislation, but those are kind of the three high-level bullet points. I have no idea what that means, but I just thought it was hilarious that somebody got that on their phone. I'm sorry, but sharing is unavailable at this time. I don't know what they were using, but I just found that screenshot. So some of those three problems I just mentioned were kind of the driving force of this whole WAP thing I'll talk about in a second. I guess I'm speaking one slide ahead. But of course, everyone knows the work format. It's a container, it's a standard, it's got the full HTTP transaction in there. Great job by the preservation working group to help define that in the IPC. It's a ISO standard. But one of the really cool things about work is you can have effectively arbitrary metadata records in there. So if you had your capture of a web page, you could also just insert a metadata record that has whatever information you want to put in there. The standard allows for it, whereas previous formats, such as ARC, really didn't explicitly support that. The other format we use a lot in our toolkit, and many of you I'm sure are familiar with, is this CDX file. It's the thing that the Wayback Machine normally uses for keeping track of what are the URLs and what files they live in and some basic metadata. Unlike work, it's not an ISO standard. It's sort of just our conventional format. It's more or less a space-delimited text file that's sorted. And it's sort of only the essential metadata that Wayback needs to do its job. So you have your URL, your digest, your timestamp, those kind of things. But it's really limited. I mean, in terms of doing interesting analysis, what you can ask of the CDX file is pretty limited. You can say, well, how many 200s or how many HTML text files, that sort of thing. But beyond that, it just doesn't have the information there. So that led us to this WAP thing. And it's, yay, yet another data format, or metadata format. And, ooh, yet another metadata format. Like, how many more metadata formats do we need? The idea is that the WAP is trying to sit in this middle ground between the WARC that has everything, all the stuff, and the CDX, which has very limited stuff. So we want something in the middle. And the idea was, what we're going to put in the WAP is just the stuff that enables a lot of interesting analysis, but is not so much data that it prevents us from sharing it. And that's kind of the other part of this motivating force that we haven't talked too much about. Was one of the original goals of WAP was we could share these. We would sidestep copyright, privacy, that sort of thing. Yeah.
So that's a really important point. So there's a clear sense from the international community that this content would be considered shareable metadata that we can distribute freely, not just within our community, but with researchers, with the public if they want to, take this content and mine it. So it's still very experimental. We don't have enough examples yet, but between different institutions within the IPC pushing these types of data sets out, we're hoping to make it a de facto standard.
Mm-hmm. Yeah.
Not the metadata format, but the fact that we can share metadata without anyone.
Yeah. And obviously it would be up to everyone's legal regime whether they can or they can't, but that's sort of the goal we're trying to achieve. And like we said, we want your feedback. It's a work in progress. If you look at it and say, wow, what you guys have included, we can share that. That's great. Or you might say, we can either more, or we have to take something away. That's the idea. So we kind of made a first draft of it at the archive and implemented tools to produce and consume this sort of first draft revision. And we'd love it for more people to use those and tell us if they're any good or how they can be improved. The other really cool thing is WAP is actually WARC. Like I said before, WARC allows you to insert a metadata record into a WARC file. So we said, why not just use that? So we're already using our WARC standard that we put all this time and effort into building as a community. And these WAP records are just metadata records. So it's a standard WARC metadata record according to the ISO specification. It's got a refers to header. It says, hey, this is a metadata record about this actual WARC record over here. The payload is JSON. It's compact, it's hierarchical, and pretty much every tool in the universe now seems to support JSON. In my opinion, JSON is what XML thought it was going to be, turned into JSON, kind of. But like I said, it contains what we're calling the essential metadata. And to Chris's point, this is what IA feels is shareable.
And researchers,
And
in the United
researchers.
States who are close to us. So.
Yeah, so it's kind of like us and a few friends kind of said, well, we think this is the stuff we can share and the stuff that would be useful, finding that balance point. But of course, we want the feedback and we want your input. But yeah, so it's mostly page title, links with the text, which Chris was talking about before, and then like HTML meta keywords, that sort of stuff. So the headers and that sort of thing. In addition to what you would normally get in a CDX file, like the IP address, the timestamp, and all that.
So when you say links, this text is one piece or is a links or
So like in an HTML page where the href is, the href, and you have the URL, and then the little piece of like the click here text, that's the text that I refer to here. So, you know, that's
the text of the page.
not the text, but just the text of the link. Yeah. Yeah. This is a really dense looking example. I don't want to try to read it all out to everyone, but the point is just showing that, yep, it's a work record. And anybody that is familiar with the work format can see that. It's got the appropriate headers, it's a metadata type, it's got the target URI, the date, and all that stuff. So, you know, I don't want to read everything below, but just to sort of reconfirm that yes, we are using the standard, the work standard already. It's just a plain old metadata record that happens to have a bunch of interesting JSON stuff. To kind of reemphasize Chris's point, you know, the WAT is trying to be in this middle ground between the full work content and CDX files. So this is just sort of a visualization I came up with where I think I took our Y05 crawl and basically said, okay, however much the original works are altogether, whatever it was, like 100 terabytes, 360 terabytes. So, you know, if that's the yellow square, the WAT is kind of, that's the proportion that WATs make up, and the CDXs, of course, are very small, you know, in size comparatively. So just have a visualization to give you a sense of the relative size of these things. So that's kind of the format. You know, saying we have work, we have CDX. These are things we can maybe work with internally. Of course, WAC is this thing that we want to have not only be useful for analysis, but also shareable. But having like a toolkit, okay, so we got formats, we got data, what can we do with all this stuff? And in the context of Hadoop, and again, this presentation was more aimed for actual researchers. I was giving it to some, you know, graduate students at Stanford, other universities. So these were kind of what we were shooting for. You know, you could run any kind of interesting analysis. You can ask cool questions. And it's not too hard to use. I mean, we don't want to say, okay, step one is write 10,000 lines of Java code. And then you can ask an interesting question because, you know, PhD students don't have that kind of time. And we wanted to use, you know, sort of existing projects. So what we decided to do was kind of put some better structure around our use of Hadoop, and in particular this thing called PIG. So these are Apache software projects, open source, completely free, freeze and beer, freeze and speech, both. We talked about that last night in Water Syllabus, the difference. So you take the software, you take these different types of file formats, and together you kind of have a toolkit. One question that does come up a lot that I just kind of want to throw out there is, you know, a lot of these things, when I give examples, people just say, why don't I just use a database, man? I can just shove this in Oracle or whatever and just write a query and it comes out. And it's like, well, that's true. You know, and I'm not saying, what I'm describing here is not to be prescriptive. It's sort of more descriptive. This is what we're doing. We think it works. You might have a different opinion. You know, web data is semi or unstructured, depending on your opinion. It's, you know, heterogeneous, it's nasty, it's the hardest data set in the universe to work with, I think. At that point every day, it's whatever terribleness is imaginable exists on the web. You know, and if you load it on the database, you're kind of duplicating it in another form, and it costs a lot. I don't know. In my experience, a billion record Oracle database is pretty expensive. Let alone a 330 billion record Oracle database would probably be really expensive. So yeah, you know, it's hardware costs money, but the software is free, which is nice. And it's in great use throughout the industry. I've been going to the Hadoop conferences for the past couple of years, and every year the attendance is literally doubled. I think it went, you know, like 200 people, 400 people, 800, 1,600, 3,200 last year. So, you know, in the first year it was a bunch of, you know, nerdy code geeks. Last year it's the keynote is being given by Jeff Bezos of Amazon, and there's like the executive vice president of IBM, and you know, so it's got massive traction within the industry. Facebook.
The food at the conference got better and better with the years.
Strangely enough, that tends to stay the same. I don't know what's going on there, but there's just more of it. So just to kind of breeze through a little bit, Apache Hadoop, the whole idea, distributed computation framework. A lot of super cheap boxes can do the work that you would spend 100 times more to buy one big box, if you could even build a box that big. Like I said, it's open source, it's Apache license, everyone's using it. And it was inspired by this Google paper back in 2004. But this is kind of taken on a life of its own. The sort of key components to this technology platform and how we're using it, there's really two pieces. There's storage and computation. The storage piece is called the Hadoop distributed file system. So you have distributed storage, you have replication, it's scalable. When I wrote this slide, the largest then known Hadoop cluster of storage was 60 petabytes. Now I think there's over a dozen companies that openly talk about that they have over 100 petabyte Hadoop storage clusters. So it seems like sky's the limit. I think Yahoo has 200 petabyte Hadoop clusters. Facebook, I'm sure, is just as big. And then you have this distributed computation. You write sort of at the core some Java functions, and it distributes your work across the whole cluster, runs whatever you want to run, brings all the results back together, and gives you your answer. And some of the best aspects of this whole system is it tolerates failures very well. In some of these companies where they have 4,000 node clusters, there's no way every machine's going to be 100% on all the time, and every disk is going to be healthy when you have 50,000 disks. So a lot of failures are just sort of automatically dealt with, which is really nice. Like I was saying before, you could use cheap commodity hardware. Believe you me, at the archive, that's what we use. The cheaper the better. It scales horizontally, and you can use heterogeneous hardware. It's really nice where you can just say, hey, we used to have 1.5 terabyte hard drives, now we have 3 terabyte hard drives, but I'm not going to replace all my 1.5 terabyte hard drives at once, but I'll just replace these 4, and then I'll do those 4 next week, and then these 4 next year. So you can really mix and match like all this stuff. So, for us at the archive, it's a great fit for our sort of the way we do our resourcing, buying cheap commodity hardware, replacing stuff when it fails. We don't have like every 4 years we spend a ton of money and hope that hardware lasts for 4 years. We're always buying, small amounts of stuff, every month. The cheaper we can get it, the better. So it works really well for us. But oh no, is it the magic word Java? Who wants to program in Java? Anyone? Does anybody have to program in Java? So that's kind of a perceived barrier, right? Like I said before, especially for a PhD student, if I said, okay, your first step is write a massive Java program, they might say, well, good luck, have fun. So Pig is a scripting language, so no Java required. I only have about 3 minutes before lunch, so I'll just give a couple really quick. I'll just give you the basics, but it's time to wrap up the list. So the idea with Pig, which we can walk through some examples after lunch, we can really look at the scripting language, but the idea is it's easy to use, kind of no programming required almost. At a lot of public companies, analysts use it. So I know at Twitter they have like a team of 20 analysts that write Pig scripts all day. So these aren't computer science people. They would never know how to write a Java function, but they're using this Pig language to write their analytics tools. And you can extend it with Java functions if you want. This is like one little example of one that I did where, just trivial example, where I said, hey, I have a set of WAC files, those WAC files we talked about, and I just want to extract the HTML page titles from them. So the page titles are actually in the WAC files, so we have this little script that could be run to extract out all the HTML page titles from a body of WACs. So from our, say, Y5 crawl that we've talked a lot about, we can get all the page titles out. The key thing about the Hadoop system that I like a lot as a developer is the way that it scales. So if I have sort of the local copy of Hadoop running on my laptop, I can write a Pig script, test it, debug it with maybe a tiny data set, just like a little sample, maybe like one WAC file, and be like, okay, I got my script right. Copy my script to our Hadoop cluster and just say, okay, now run that exact same script on 100 terabytes of data. I mean, that's how it is. So it's not like, oh, I ran a little script on my computer, and now if I'm going to do it on the cluster, I got to totally redo it in a different way. It just goes from one to the other seamlessly, which is really, really nice. So another classic example is simple counting at scale. Like, if we have billion page collections, we want to ask simple questions. You can do these with a couple lines of big script. Let's kind of talk about that. Another example, which we can go into over after lunch, which I always find interesting, is trying to find closest captures. And this is sort of where that link information comes in. So in the WATS, if we have all the links, you might say, well, gosh, when I'm in the Wayback Machine and I click a link, man, all of a sudden I jump 2 years ahead in time. And that's, maybe I like that, maybe I don't. Wouldn't it be nice if we could sort of measure that ahead of time? So we could say, well, this collection, what pages have their links would actually go to another page close in time. So this is just sort of an example we can talk about later. There's some code. We talk about similarity stuff, so we can do some similarity analysis, which I'll talk about later. And the last one I'll mention here before we break for lunch, this is a personal favorite of mine. So anybody in the room feel confident enough on the next slide they can 100% tell me with high confidence what the one language on the page is?
You don't want to see this.
What's the one language on this page? There's a lot of languages, isn't there? A lot of scripts, a lot of different stuff. I hope that's the encoding, but what's the human language, right? Is it English? Is it French? Is it Spanish? A lot of the web has multiple languages, and so it's a really kind of hard problem. How many people use Chrome, and sometimes it pops up that little thing that says, hey, this page looks to be in language X, and should I translate it for you? Is that thing ever wrong? Yeah. Ever look at a JavaScript file in Chrome and it says, I think this is Indonesian or Portuguese or something? It's like it gets computer code terribly wrong. But anyway, the library that underlies that feature of Chrome is open source. So I took that library. I'm not a linguistics expert by any sense. I just think it's an interesting topic. So I took this open source library, created a Hadoop sort of wrapper for it, and then actually yesterday, or 2 days ago, we were in session, I ran it on our entire Olympics collection. And so I have posted the results of that. So for our collaborative Olympics collection, you can see the results of how many pages are in which different language according to this tool. And like I said, it's not perfect, it's not 100%, but at least might give you some interesting view onto that data set. And that's sort of it. And here's the last slide before we go to lunch. And I'll hopefully show you some other more fun examples later. But a bunch of resources. This is just an HTML page off my the archive, so someone could point hair tricks at it and harvest it if they wanted to, for example. But anyway, a bunch of stuff. Hair tricks, Wayback Machine, toolkits, everything. On my blog, I talk mostly about the Hadoop stuff we've done at the archive, so hopefully it'll be interesting things to be found there. But I think that's sort of the tour de force of the toolkit. I'll run you through right before lunch, so like I said, there'll be plenty of time afterwards to go into a lot more details.
Are there any questions of Aaron initially, and then it would be great to understand quickly how people want to sort of drill in further, maybe with just a quick show of hands, like how many of you want to drill further into sort of the technical detail? Do we have other topics that are of interest? I know some of you just have to leave, and that's okay too, so don't feel bad about that. So quick show of hands, how many would like to drill in the more technical detail, get into the scripts, maybe experiment with some of the use cases that Karen described? Anybody? Okay.
You don't have to, it's okay.
Is there anybody who would like to get into more of the like use cases, workflow assembly, even just sort of business justification of this type of work? No one will be offended. Anything else that people would really like to particularly focus on after lunch?
There were people who were interested in the problems of sharing rights.
Okay.
Yeah. Also, I heard you talking about the MongoDB implementation.
Oh yeah, why we moved off of it?
Because for a long time, you covered the fact that frontiers were distributed.
actually, let me quickly see when they say we're supposed to go there. So I guess 12:30 to 1:30 is lunch, so we'll reconvene at 1:30 for anyone who's still here and would like to dive